Hello everyone and welcome to yet another PTC Nordic Talks webinar. We are excited today by having Anders and Pradeep from Vestas for a session on raw materials management in PTC Windchill. But first, a very quick introduction about myself. My name is Anders Præstholm and I'm the Alliance Manager for PTC in the Nordics. And we are running these webinars same time every week. And we are inviting customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. All the past webinars have also been recorded and are to be found on the registration site. The agenda for today is first a very quick introduction about PTC by my colleague Carl from the Customer Success team. And then Anders and Pradeep will start by introducing themselves, touch base on a few challenges and how to address these, and then explain some of the business outcomes. And at the end, we are also having a Q&A session, so please keep your questions to the end. So now over to you, Carl.
Thank you, Torbjörn. So PTC is maybe you can go to the next slide. Sorry, I should have said. PTC is an international software company with headquarters based in Boston. We are developing software mainly for manufacturing companies since 1985. We offer tools for the digital transformation, such as CAD for design, PLM for managing data, IoT for connecting products or manufacturing operations, and augmented reality to visualize and interact with the digital thread. So to you, Anders.
Thank you very much. Yeah, today's topic is called raw materials in Windchill, and we will dive further into that. But first of all, a small agenda where we will look into the company and the speakers. We will look at the requirements and how it has been solved, and then what is the outcome. And right after, or as part of the outcome, we can have a look at the questions that has popped up during the presentation. Vestas Wind Systems. I hope you know the company, but if not, then we can say a few words about it. It's one of the global leaders in sustainable energy, providing different solutions onshore, offshore, and also service. More than 25,000 people are employed, and there's a footprint in more than 85 countries worldwide, with manufacturing facilities and also design facilities globally spread. So a few words about the speakers. Myself, my name is Anders Præstholm. I'm an external consultant. I'm working for Vestas and have done that for quite some time in projects with an end-to-end focus, also with a business focus in order to achieve a better traceability and a digital thread in what we do. Pradeep?
Yes, my name is Pradeep. I'm representing the standardization department in Vestas. Our aim in the standardization is to have a highly standardized components across different platforms, onshore and offshore products. And we aim to reuse the components or assemblies across different platforms. We basically also work on standardizing raw materials and base materials across the regions, and we ensure these data is digitalized in Vestas. Currently, the challenge what we have is the data what we have in Vestas is not in the digital form. So we are supporting the Windchill or the PDM departments. How do we digitalize this data in Vestas? So it will be enhancing our needs going forward and also support different value chain in Vestas. We also aim at standardizing bolts from smaller components to larger components across different platforms like bolts, pumps, or motors, or heat exchangers, or whatever. So basically, in this meeting, we will show you what is our challenge right now, what Vestas has on these raw materials and base materials, and how we are addressing this challenge with the solutions what we are developing. Right. So, Anders.
Thank you.
Yeah.
If we look at the requirement behind what we have done in this example here, then it's a question about getting a better support for what we have decided to define as raw materials and base materials. And it could also be a combination of different raw materials. It is so that when you do turbines, then the raw materials and the base materials, and base materials is the same as substances, if you're familiar with that term. It plays a special role for turbines because, as you can see in the picture, we use a lot of steel. We also have a huge consumption of composite materials for the blade. And at some areas, we are actually pushing the physics to the limit. So it's important that we have the raw materials and the base materials under control. So for that reason, we would like to have that under change management control, which was one of the gains from this project. And we will also be in a position where we could specify the quantification of raw materials for planning, and of course also have that under change control. As you can imagine, the amount of steel and composite materials are huge, and we have a huge footprint in the market. So planning is a vital part of making sure that everything works as expected. And with the challenges that we see in the supply chains these days, it is only going in one direction. If you look deeper into how we have defined the different objects that we're going to talk about here today, then we have the base material definition. This is actually the same as the substance, and this is how we're actually going to describe the different materials that are used in certain either raw materials or materials. So the base material is a definition that you cannot purchase anywhere. You don't have a material number for it, but you have all the detailed material properties hidden behind this object. In our system landscape, we are storing that information in a system called Granta from the provider ANSYS. With regards to raw materials, our raw materials has been handled as regular materials until now, but we need to make a change here because the raw materials are behaving a bit differently. But we will also like to be in a position where we can, together with our suppliers, be able to specify the raw materials. So for that reason, we would like to indicate that we are operating with a material, a special material, a raw material, so it's easily to identify in our systems. The last one here is called a material system, and it's actually, if you cut to the bone, it's just an assembly of other raw materials. The reason for bringing in a new type is that we do certain laboratory works behind the approval and the development of raw materials and combination of raw materials, and the outcome is what we call a material system. You can see an example over here to the right, where this is from the composite area, where we have the first example up here, which is the fairly simple one, where you have the resin that is a main component of a blade. It consists of two raw materials, the base resin and hardener, and of course it needs to be provided and used or issued in the right quantity. The combination is stored as a material system and is under change control and being stored in Windchill with references to the detail pages that we have here in Granta. We'll see that in a different picture in a while. The combination between fiberglass and resin is also under laboratory control and stored as a material system, and stored in Windchill as an object, and under change control, of course. By doing so, then this information is part of the specification for not only the different segments of a turbine, but the whole turbine. It also gives us the ability to utilize the standard functionality that is available in Windchill, like interchangeability, handling alternates and substitutes for the different materials. So we have aimed for this setup, so we have a standard solution as close to out of the box as possible. If we take a different view, a more system oriented view, you can see that it's we have a fairly complex setup with a lot of so-called gateways or interfaces. But what you should focus on here is what we have in Windchill, where we operate with the raw material and the material systems, which is more or less the same, but we have the reference to the base material, which is stored over in the Granta system. So we hope that PTC will soon provide the capability inside Windchill, because then you can probably imagine that we can simplify this picture quite significantly, getting rid of a number of interfaces. But nevertheless, the setup will be more or less the same. And what we are aiming for here is to have a single point of truth. We have our digital thread maintained based on the information that we have in Windchill. And it has to cover all the things that we do, meaning that we at any time are able to find the right version and utilize that in our different CAD systems, but also in simulations. So we are absolutely sure that we are operating with the right version, and it is an approved version of both the raw material and the material system that we are operating on. If you look,
Anand,
yes.
I have a small request for the PTC. So as you can see, it's really a complex system what we have in the investors right now. So I'm requesting PTC, please consider the probability of developing the base material database in Windchill system, or a functions to anchor all the base materials for the raw materials in the Windchill system. That will be so great. Then the complexity what we have right now in Vestas, not only in Vestas but in other industries, can come down by anchoring all in one PTC or the Windchill systems, right? All the data. Yeah.
Yep.
And we can support you how to build that system if required. Yes.
But as of now, we have this setup, and here we utilize these gateways to make a link between the raw material and the base materials. It means that we have the right foundation to do design. We do our composite design here in this system called CATIA, and it fetches the information via a component called LDM. So we are in a situation to get only approved content into the design. The design of a new blade, it takes quite some effort, a lot of hours. So it's super important that we are operating on approved material, where the laboratory has done the work, and we are absolutely sure that this is what we are utilizing. On the other hand, here in the mechanical world, we are also in a situation where we can make the link from either our materials directly, or if we're utilizing raw materials like we do in towers, and link that back to the base material in the Granta database that we have here. So that gives us an overview of the whole structure behind a product. down to the level of substances that are stored here in this database. Look at a practical example. It's a little busy slide here, but this is actually how we can connect the different areas. If we have a CAD model here, then we have the ability to assign a base material to the CAD file. This is a more comprehensive information about the base material than just the simple material database that you have in a CAD system normally. It means that we are in control of a lot of other parameters that can be utilized for simulations. And this link makes sure that we have the absolutely right information about the base material or the substance behind our CAD models. And when we check that in, then it's actually maintained by Windchill. You can see we have the base information, the base material information stored here in the database, so it's visible to everyone. Sorry. It's also possible to create a standalone WT part, which is the same as a material, and link that to both the CAD file, but also to a raw material. And this is actually what is shown over here to the right. So if you look at the bottom here we have a material with a CAD file and also a raw material. So it means that we are in a situation where the material is specified not only by the geometry from the CAD file, but also with information and about the required raw material, and also the substance or the base material behind the raw material. So that gives us the full package of information, so we can utilize that not only for simulation but also downstreams in the manufacturing to first of all order the right material, but also we have the right quantity defined in the model.
As you can also see in the last right corner, there are different attributes here like base material name, raw material type, and raw material categories and other stuff. So that is where we are now digitalizing this data in the Windchill system. Currently, if you see, this data is lying somewhere in the drawings, and it is very hard to trace back all these information in one system. And as you know, we as a big company like Vestas, we want to be in control of the raw materials for the future as well. So this will give a very good indication, or this will help us to manage the data for the entire product. Around, for example, our wind turbine has around 8,000 plus components, in unique components in a turbine. So having the data for all these components in this form will give us an indication what amount of raw materials we are consuming per product, and also for the future orders what we are going to have. Yeah, so this is one of the challenge so far we had in Vestas, and this project, or whatever this topic we are showing now, is enabling these features. Of course, when we are interacting with Granta and bringing these gateways like Windchill gateways and the Creo gateways, which Anders has shown, there are some challenges. And we want, again, I'm saying, we want PTC to look into this and support Vestas like companies in building these functionalities within the Windchill system. So then it will be very quite a simple task for us also when we launch the different upgrades of Granta gateways and other stuff. All these ad hoc works will be off from Vestas side. Yeah.
Yep. So if we all boil the initiatives down, then we have achieved what we were looking for. We have the digital thread to the level of substances. We have also specified our required raw materials as part of the digital thread. and we are in a situation where we now have what we do under change management support. After we have delivered the solution, there's been some other use cases popping up where there are some requirements from certain sides of the organization to simply build an overview of content of a specific substance in the turbines. It could be steel, it could be copper, it could be something else, but certain areas of the organization are looking into this information and are looking for this information, and they can utilize the information in the base materials for such queries. And the latest one is also with regards to the challenges in the supply chain. It's a question about hedging in the market in order to make sure that a certain amount of a specific substance is available. So it's super important to know exactly how much we need for a single turbine, and this setup also support. I think time is up for the presentation, and I think we should look into some of the questions if there have been some.
Thanks a lot, Anders and Pradeep, for a very interesting presentation and all the good, hints about what we could do, from a PTC perspective as well. So as said, over to the Q&A and open up for any questions from the audience. So let's go ahead. Who would like to go first?
Yeah, Toby, this is Hemant here. So Anders and Mark and Pradeep, so nice to see you guys in this webinar. So what you are presenting here is actually the basic foundation of the digitalization, right? And without these components, digitalization will not be successful. I must commend the amount of great work that you guys have achieved here. I know this project, so I will be refraining from further comments, but it is a great job that you guys have done. Thank you so much.
Thank you, Hemant.
And we have one question also from Kim. Maybe you would like to speak up, Kim?
I can. Question is, in a couple of these overviews, it seemed like a fairly complex setup. How many different? And I could identify some of the technologies being used there. Overall, how complex is it actually? How many different platforms? I saw Creo, Windchill, Katia, some other stuff. How many different ones are there actually in this setup here?
In order to make this setup, you more or less only need Windchill, and you need the ANSYS granter to hold the information about the raw materials and the base materials. In between the two, we have two gateways, one for the raw materials and one for the base material used in the CAD systems. So you have two databases, and then you have two interfaces.
And the rest of the other boxes are the different tools we use in Vestas, meaning different like an ANSYS, Katia, and a layup definition module for the other step. So, yeah.
So you should see those as clients that we need to have in order to give access to the databases for the users. So this is the regular clients. So the two main components are the two databases, Windchill and ANSYS granter. And then we have these two interfaces in between.
Yes, and our vision going forward will be one database. That is what I'm asking the PTC. So we want the data in a central form in Windchill system, for example, and connect this data to the different tools we use in Vestas as a supporting tools for our design work. And take the data from a single source of truth, which should be the Windchill system.
Does that answer your question, Kim? Or?
Yes, thanks.
We have another question from Vesa. Would you like to raise your voice as well, Vesa?
Yes, okay. My question is, how about the reuse of materials when windmill is at the end of its life cycle and should be disposed? And do you have a material chain for this disposal and reuse?
That's actually a very good question. We are not dealing with that part in the setup as of now, but we definitely have the ability to do so because we now have the raw material and the base material under change control, which means we have them in a life cycle, and we have the possibility to extend the life cycle with disposals as well. With regards to life cycles, we have decided to not to allow revisions of raw materials and base materials from the point of view that it's so hard to
Control.
control the impact of a change in such a basic level. So if you, for instance, make changes to a roll of ply for a composite construction or product, then it can be fairly complex to look into different existing products and see the outcome of that. So the life cycle of the raw material and the base material is super relevant, and it could definitely be extended to control the disposal in the end as well.
How about then composite materials like turbine materials?
Yes.
Can you dispose those and reuse those?
This is one of the major hot topics currently. There are a lot of experiments going on with regards to this, because it is a fairly it's a mix of many raw materials, and they are, of course, for good reasons, they are heavily integrated into each other as part of the composite production. But there's a lot of experiments going on these days in order to simply split the different raw materials again.
Okay, thank you.
Yeah, there are a lot of studies going on how to reuse these or how to come up with a reusable materials in terms of composites actually. But yeah, of course. Yeah, if we find a solution, definitely the aim of this presentation is to show you how we are moving our journey towards digitalization. And the first step what we have identified is okay, let us focus on the raw materials and the base materials. Of course, we can take in a lot of other things like the sustainability, the carbon footprint values and other stuff, but that is our roadmap in the coming days.
Thanks. We have another question also from Dina. Would you like to raise your voice as well?
Yeah, sure. So as far as I understood, raw material, there is a possibility to attach geometry, so you know how many plies you need for this geometry. But as far as I know, for prepreg, it's also important that the raw material has some specific length. For example, 1 meter or 3 meter or 5 meter. Are you able to control that parameter in your system that you right now using?
Yes, that's a super good question. If you have a base material representing the prepreg, which is a composite already, right, where you have different substances represented in the base material. Here we need to build a number of material systems representing the different geometries that are provided by the vendors. That could be different lengths, it could be different widths. It is so that the design and manufacturing processes for the blade will be different depending on the raw materials here. So this is one of the important parts of the specification of raw materials when we build the database in Windchill. it means that for the same material, we might have several material systems that can be utilized for the composites.
Thank you.
And that option is there. We can anchor different lengths, widths, and heights, or whatever for the raw material. So that is the material system. That is the system we have developed internally in Vestas. Yeah.
Thanks. We have another question
Thank
also
you.
from Yoon. Would you like to also, to raise your voice and ask the question? Yoon?
Yeah, thank you for the interesting presentation. My question is related to the real benefits or economic benefits of using this approach. Basically, material is always used, or different material always used in conventional way. In the past, we always do that to verify the benefits or by using different materials or optimize it. So what is the real economic attraction from your approach here?
That's also a very good question. It is so that in order to achieve and to reach the financial targets that we need to deliver when we design new components, then we of course need to know what is inside our products, and by introducing this next level of detail, then we know exactly how much material and combination of materials that we are utilizing. So it's actually not only a question about economical figures or finances. It's also a question about the carbon footprint, and also a question about the amount of certain substances, because we are in a situation where sometimes it can be hard to get the amount of substances that we would like to, simply because Vestas is a big player in the market, and the consumption of certain substances can be hard to get, especially in certain areas of the world. But it's not only the cost; it's also, of course, the footprint, the carbon footprint, and also the supply chain that is playing a vital role for the content of the products. And this can be visualized and be more transparent with this setup.
Yeah. Adding to this, I don't know if you guys are aware, the vanadium and cobalt content is skyrocketing right now, the cost of these materials, and we use them a lot in our turbines. So this will give us an indication of our prices, what we should plan for the future. So there are a lot of possibilities by detailing, as what Anders says here, about these raw materials and base materials. Yeah.
Thank you. We have time for one last question from Katrina. Would you like to ask you questions?
Yeah, hi. I was just wondering, when you say that you can't revise your parts, but you supersede it, what will happen to a material that has been superseded? Can you still use it in other material systems?
Yes, it is of course a configuration we have chosen to go with, but the idea is that we would like to be able to continue with the old material for the products where it's relevant, and by doing or using the supersedence functionality, then we're actually introducing a new raw material or base material for the future products, and then we are not going to touch the existing ones. So the idea is to make sure that we're not introducing a risk into our production by changing a fundamental element like the base material or the raw material. But we are absolutely sure that we are starting on a fresh. We have a fresh.
How do you make sure of that? Is the designer just looking and seeing that this material is superseded, or is there some kind of warning when they make a new bill of material, or
yes,
how?
that's okay. Anders, can I take that question?
Yeah, please.
Yes, the system is built in such a way that, of course, when we supersede old material with a new one, and in the new products, if the designer is trying to use that material, he'll get a warning saying that yes, you have to use the new material. The old material was superseded, so he'll get a kind of indication or warning message.
Okay, thank you.
Time is unfortunately running out, folks. So many thanks everyone for joining, and of course a special thanks to Anders and Pradeep for sharing a lot of great information here. Very exciting. And as Friday next week is a public holiday, the next Nordic Talks will be on the 22nd of April, on the topic of artificial intelligence in production. So stay tuned for that. And with that, I wish you a fantastic weekend and Easter holiday as well. So take care, guys.
Yep.
Bye.
Thank you.
Bye now. Thank you.
Bye.
Thanks. Bye bye.